So the purpose of this lesson is to learn what events are, what typical events you should be using when you see them, and how to handle them, and how to use them to make your code cleaner, to separate unnecessary lines from your business code. So let's get started. First off, before talking about events altogether, let's talk about delegates, because events need something which could handle them, and that something is a method. And a delegate is a method which is as a variable. So if I write something like public delegate void handler, means this is my own, and then so it means that this is my own custom delegate. Just like a method, it has an access modifier, it has a return type and a name, and it can take params if needed. So this is a delegate. The only difference is that it has delegate keyword, meaning that anything that is void and takes no parameters can be set to this handler. So I can test it and say that my handler is, maybe not, but add command won't do. I can make a method which returns nothing. So public void something does nothing. So this way I defined my own handler, and if I say handler, then this way I define it as a parameter. So it's quite similar to a numerator, where you define it and then set a value in as a property or field. In this case, as a field. So delegate is a variable for a method, and later on we can do something like handler and call it just like you would call a method, except with a variable name. So, but delegates were used long time ago, because in these days we have implementations of delegates, which come essentially in three forms. We have actions, we have functions, and we have predicates. Actions are void. They are functions which return nothing. So if I say action do something, that means that this is a delegate of type void, of return type void, which takes 0 input. And if I wanted it to take some input, I could put this as a generic type like this. So right now it would mean that my do something is a function which takes a single argument as an integer. So this is delegate, which an implementation of delegate, which is an action. I'll actually write some tests right now. So let's go to lesson 6 class and define our action, and let's now assign a value to it. So I'll just print something to console. Action called params, and we pass in some numbers. So in this case we have do something, I'll call it differently, action 1. So our action 1 gets a value of do something, and let's make it all static for testing. Actually, let's make it non-static, no need. We'll create the lesson 6 and then hit run. Okay, so we have our action 1, which is the same as, I'll write it, public delegate void, which takes delegate action 1, which takes a single int as a param, and delegate action 1, delegate 1, they are the same. So I can do and try it, do something, and it will be the same. Okay. So action is the first implementation of a delegate. The second implementation of a delegate is function. So the only difference is that it returns something compared to action, which is void. And for that reason, since it returns something, it takes at least one or more generic parameters. So let's say I pass a number and I return a number. I call it function 1, and for that purpose I will need a method which gets a number and returns a number. So that's equivalent of a function which can be assigned to function 1 variable. I'll call this something action. Okay, so that's the second one, and last one will be a predicate. So it takes in it's a bit different thing. It takes in a criteria. And I actually use it a bit. I actually don't really use it, so I'll just leave it behind because I will mess up by explaining it probably. You didn't know what was. I'll explain tomorrow. I need to make my own research about it as well because I don't really remember using it. It consists probably lambda expressions and arrow functions, and I'm bad with those. Okay. Do you have any questions so far? Anything at all?
No, not so far.
Okay.
Tell you to piss off. Wait.
Okay. Were you familiar about delegates before?
No, this is all new to me.
but you find this easy to understand.
Yeah,
Oh,
I'm
okay.
slightly keeping up.
Okay, so based on this, um, in method run right now, you see we have action one, delegate one, and
Uh-huh.
function one.
Hmm.
How do we call them?
Um. Oh, using a delegate? Would you use a delegate for that?
They are all delegates except action
Oh,
one is an action, delegate one is a delegate, and function one is a function. They're all delegates except a bit more specific.
okay. So how would you thingy call them?
Just like a method. You do
Just like a
action,
method, alright.
yeah, action one, because they are methods. So it needs a number, so you can pass 5. Delegate is the same as action one, so you just pass 5. And function, we can also pass 5, let's say. And it returns a
Okay.
number, so result, we can set it to this. Uh, I saw Reiko wanted to invoke it, but invoke is not needed. Uh, the thing about invoke, it's, at least to my understanding, to my experience, it's it's the only useful case where I needed to use invoke when I was working
Uh-huh.
with WinForms, when I wanted to call a method from a specific thread, from a thread that a form was created at, so that it is called so let's say so that a function which updates controls get called from main UI thread and not some different thread, because it will give cross-thread exception otherwise. So that's the only case I needed to call invoke differently. The second case is events,
Okay. Uh,
where you call an event handler, which is kind of the same, kind of. Uh, so if this is null, it will give null exception. Whoops. This is also fine. Uh, in this case, it's needed because, so I'll return back to this, but I think this is what Reiko wanted to do. Uh, in case those are not set, you should check if they're set, else you'll get null reference exception, because essentially they're just pointers to methods. And I will change my internet fast.
no, you sound fine to me. I think it's just Rico that has problems.
I'll still make it a bit better since I have an option to do it, so one
Alright.
moment. Okay, I'm back. It should be better now. Okay. So, okay. Uh, so basically, the thing why would you call invoke is, in this case, for sake of using it in the same line with the uh, null check operator. Uh, so in this case, you can call the method
Okay.
while checking if it's not null. Uh,
Alright.
in other case, I'm not sure if it's different. The outcome is different because you call it from the same you're still calling it, and I don't see any differences. Uh, like I said,
Just,
yeah.
this is a shorter way of saying it or something.
Sorry, I didn't understand.
Is it just a shorter way of saying it? Well, hiding it.
Kind of. In event handling, it's kind of a must. Uh,
Okay.
just like a way to secure yourself. I-
Yeah, I get that.
yeah.
Alright, I see.
Uh, and if you don't check and invoke like this, null reference exception, but in both cases you can get null reference exception. So I'm not sure what's the difference, and I should look it up and give an explanation right after the lesson. So I'll ask. Okay, so this is a delegate, which is a variable as a function. A delegate itself is a pointer to a function. In other words, that's all it is. So it has a reference, and for that reason, if you don't assign it to some value, to some other method, then you'll get null reference exception, because it will be null.
What's the point of it then?
The point of what?
Of a delegate.
Okay, so now you see where I'm going. I'll show you
Okay.
what's the point of it. So, like I said, the topic of this lesson is events, essentially.
Okay.
So, events are basically triggers which get called by certain objects, in general, by objects when something happens. For example, when your program starts, you probably have some event on program start, or when an exception happens which you didn't handle, you can handle it in an event if you subscribe to an event, unhandle exception. Let's simulate this. Let's make a global exception handler. Not global, but for lesson. Let's handle lessons exceptions that happened, but not in a try catch, but in an event. So we have an action. Let's make another action. We actually don't need an action. Okay, so application. I think it was application. Nope. Unhandled exception. I don't really remember the namespace for it. App domain. Thank you. Nope, not that one. Current domain. Yes, current domain. Current domain. Unhandled exception. Thank you. Why isn't it giving it me autocomplete? So, how do you see events? First thing, if you go and say current domain dot, and then you see IntelliSense, which says which says what current domain has. So it shows which methods, which properties, and which events does it have. And in Visual Studio, event is displayed as a lightning icon. So if you click on lightning icon, you'll see a bunch of events that current domain has.
That's the only form of events I've used so far.
Yeah. So the event I'm looking for is an exception. So when unhandled exception happens, I would like to handle that event. And I say that I handle events by subscribing to them, and I subscribe to events with += sign. So in this case, we have an object which sent an event and an object which represents data which that event transferred. So let's say when an event happens, I will when an exception happens, I'll log it. uh, I'll write it to the console, I mean. So unhandled exception events args are essentially an exception. So I can cast it an exception and I can take a message of that. Too many brackets, I think. One more. Okay. Exception object. That's the one. Right. Okay, so if we hit run now, actually let's make it more messed up. I wanted to assign those, but let's get a null reference exception by not assigning those. So let's run it and see what happens. I didn't call this yet, so let's go to our program and lesson 6 run. Let's create lesson 6 first. So var lesson is new lesson 6 and lesson run. Let's go. So we get an exception, but what did I want to do? I wanted to stop the program so that it doesn't close the window immediately. So console.readline. Let's run again. It's still through an exception, and for some reason it didn't handle it all. Not sure why. Okay. Did it unfreeze now since I stopped? I was.
Sorry.
Did Visual Studio unfreeze? Reiko said it froze.
No, not for me.
Okay, that's weird, Reiko.
I can still write random comments.
Let's comment all those out. I wonder why didn't it hit? Why all of it didn't hit the? Oh, okay. I see.
Do I? Is that?
How do I do that? Do you know? To enable
No.
console sharing.
I don't know, but I've got a debugger operations taking a long time to complete. Click cancel to. God damn it.
Oh crap.
I have to.
Well, basically, when an exception happens,
Yeah.
it continues. It hits my my method, my event, but then it continues to run and it wasn't handled,
Okay.
and it gets fucked and it breaks it anyways. That's what I meant. Um,
I'm just gonna have to. Yeah, I know. Wait.
oh, didn't know that. Okay. Let's cast it. Thanks, I didn't know that. Uh, just e-handled. Are you guys back?
Yeah, I'm back.
E-handle didn't really work. Handled. Well, basically, there's data, H result, help link, inner exception, message source, tag trace, and target site, but nothing rings a bell compared to E handled. And E itself, the argument is terminating and exception object. Those are the two. I and that one is read only as well. So I don't know. Not sure. In any case, let's uh, uh, pu- 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 um,
Rider.
mm. So in this case, we hit run, we throw an exception, and it hits our event, but it continues to run, and that's why we continue to have an exception there. Um, how do we cancel the running thing? Um, we could put everything as a task and run it as a task and then cancel that. But then it will need a cancellation token and it's out of scope, and that's not the point. So um, mm, mm. I ran it again. Did it crash?
No, it didn't crash, but it showed a exception.
Oh, okay.
Modified with tool.
Mm, uh, I'll leave it there, but basically, this is some of the pre-made events that you can subscribe to, and there are a bunch of those, and basically every more complex object with a state has one, one or more. So in this case, a domain has an event which gets hit when an exception happens and you don't handle it, and you can do something to handle it, like logging it. Uh, this is one of the ways how your exceptions that you cannot handle should be handled.
Okay.
But I mean, it's not something that you can handle. It's simply something, let's say, when it happens, you can log it as well, or do some extra actions before you completely terminate it. Like, just not to ignore it completely, not to be unaware that it happened, but you can do something when it happens. And in our case, what happens is that we print a message about the exception, and in this case it's null reference exception. Oh, in this case it's I have the power of God and anime on my side exception. So yes, this is an event, and this is how we subscribe to it. And if I want to unsubscribe from an event, it's the opposite, minus equal sign, and that means that this method, current domain unhandled exception, it no longer subscribes to unhandled exception. Minus equal sign versus plus equal. With plus equal you subscribe, and with minus equal you unsubscribe. Okay.
So I got a question.
Yeah.
So with the plus equals thing, are you able to do that as like theoretically as many times as you wanted, and
yes,
it would go through all of the events
yes,
and run them all?
Yes.
Nice. Thanks.
Yeah. The thing is that, let's say you destroy this object and you don't unsubscribe. I think bad things can happen, and before you destroy something, before you null reference this, you should unsubscribe. You should make dispose or something. Okay, so that's a basic example. Let's move on to a more interesting one. So let's go to complex operation class. Actually, to command runner class. I'll rename it fast. So we have our command runner class, and this class essentially has one problem. It had one problem before. Before we had a step of a complex operation, for example, which would need to be reported, and its progress needs to be reported and logged, displayed in some UI, let's say in a console. When an operation starts, you need to say that it started. When it ends, you need to say that it ended, and you need to say how much progress there has been done. And the bad thing is about it that you mix at least 4 lines in every step, because in every step you need to do those things, to say that it started, to say that it ended, to log it, and to write it to console. And to avoid all that, you can separate it and give the responsibility to log and display to something else. You can signal that a command or a step started and that it ended. So in this case, we have a command runner, and we have we have a command class. So let's go to a command class first. In command class, we have 2 events. We have onCommand start and onCommand end. OnCommand start, if you look at the run method, onCommand start happens when we start our event, and onCommand end happens when we end it. Execute method is something that each specific command needs to implement, and then you just swap execute abstraction with an implementation. So this event is a bit different from what we saw in the other one. Well, it's different in a sense that it's our own for first, and second is that it has arguments. The exception event had arguments too. It had an exception object argument. I'm not sure why it's an object though in the other one. The exception object needs to be casted to exception in order to be accepted. Maybe it's more than one thing. I'm not sure. In any case, we have two events, and this event is of class of generic class event handler, and it's a delegate actually, and it has parameters. It has arguments which will be sent when this event gets hit. So let's go to report event start args class, and as we can see, it inherits event args class. What this means is that this class can transfer arguments, fields, properties, whatever, when it gets hit. So we have report event start arguments, and it simply has a name. That means when we start our command, we say that it started, and since we transfer name with the event, we can print the name of the command which was run. And report event args inherits report event start args because it also has a name, but on top of that it has contribution, because we want to say how much progress happened while the command was run. So we have those two, and now we have our run method. If we go back to command, we have a run method. So just like any other object, we create arguments for our event. So for start, we pass name in constructor, and for end we pass name and contribution for constructor. And then we check if on command start is set. In other words, if there are any subscribers to this event, then we invoke it, and we do the same for on command end. So before we start executing something, we say that we are starting something, and after we did something, we signal that we are done. The good thing about this is that the execute method will have exactly the things it needs and nothing more. Only the things it needs, and the responsibility will be pure. It won't be mixed with something as logging and displaying to UI what happened. So let's try to add some commands to our command runner class. Actually, let's go to our command runner class first. You see it has a list of commands. It has current progress and total contribution, which means how much how much contribution per step. I think it should mean contribution per step, and this will be private because I didn't quite finish this one yet. So when we add contribution per step, we know that the total progress that the whole operation does is 100. So each time a new command is added, that contribution per step will go down proportionally, because each step will take less. And this will be steps.count. So if we have one step will be 100 contribution. If we have 2 steps, 1 step will be 50 contribution, and so on and so forth. Okay. So when we add a command, we add it to our command list. We subscribe to its start and end events, and we count, or in other words, update how we calculate contributions. This one is supposed to be remove, and minus equals minus equals. So when we remove a command, we remove it from the command steps list, and we unsubscribe from the on command end and on command start uh, events, and we update our contribution per step calculation. Lastly, how we handle the events. When our command starts, we print the name of a starting command, and when it ends, we update process with the contribution coming from report event and args, and we say how much progress was done, and um, and which command completed. All right. Contribution. So contribution is actually a different responsibility. I'll remove it. It's not needed in here. It will be easier to calculate contribution when we create steps for commands and do it from another place. So if we go to our lesson 6 class, let's delete this as we don't need it anymore. I will put this in a method and say that it is unhandled exception test. And let's put it here and comment it out as we don't need it anymore. Actually, we just delete it. Okay, so in this case, we need to create a bunch of commands. So let's do it. Var command 1 is new. So we need, for that purpose, we need to create command implementations. So let's say I really don't know what to call it, so I'll just call it command 1. And command 1 implements our abstract command. So it needs to implement the execute method and the constructor to say the command's name and its contribution. The constructor implementation will not change, but I will implement execute method. So my execute method will do a thread sleep so that it doesn't happen immediately. So sleep for 1 second, pause for 1 second, and then print and then print and say that you're executing this command. Executing command 1. Okay. Yeah, sure. So the other commands will be very similar. So let's just make a bunch of those. Call it command 2, command 3, and command 4. And rename them accordingly. And if we go back to our lesson 6, now we can create those commands. So command 1 has a name. I'll call it first command, and the contribution will be 25. It's in percent out of 100. So let's create a second command. I'll just copy paste, it's very similar. So command 2, command 3, and command 4. Command 2, command 3, and command 4. second, third, and fourth. They're all with the same contribution. And now we can put them all into command, register them all in the command runner, and at the same time create the command runner. So new command runner, and we say command runner add command 1, and we do the same to all commands. We can do for each new array of commands, and command for. I'll just call it command then. And let's do a for each. And register all the commands in the command runner. So instead of command 1, I add command. And we can do command runner dot run. So now it will do all the actions registered, and all those actions, if we look at each individual action again, they each has just exactly the things they need to do, which is sleep or whatever, and write line something to the console. It probably would be much more complex than what I wrote in this example, but this is what it is in this case. Okay. Right. So now I think it should do, and it should work. So if I hit run, we have no reference exception.
Steps is null.
Steps is null because I did not instantiate it in a constructor.
Oh.
It's a null list, it's non-existing list. So command runner, we need to create steps as a list of commands. And steps will be a private. Okay. Small changes. If we hit run now, it says starting first command, starting other command. So anyways, works, and I'll show you what the output is. If you look in lesson history, actually I'll post it on random. If you look in random, this is the output. So you can see that the progress was successfully reported, that the event arguments were successfully transferred, and that it all did what it should, without mixing in responsibilities and being separated like so. So we just created our first custom event, which was successfully executed and tested. Do you have any questions?
No.
So how is data being transferred with event? Can anyone answer?
Can you repeat the question?
How do we transfer data with event?
What do you mean by transfer data? You mean like with the report event star args type thing?
Yes. So what I was expecting with the event arguments, like we can pass variables or something like that, and move them and put them into events so that they travel with it. So that is clear. And so what is a delegate?
The representation of a method.
Um, how is it being represented? In what form? As if it was.
As it's represent. So basically, it represents a function that hasn't, or represents a function that can be executed.
Yes. So it's a variable, and we treat that and we can set that variable to whatever function we want. So it's a pointer to a function. A delegate is a pointer to a function. It's a reference type variable to a function. Okay, so how do we subscribe to an event? How?
Using the plus equals.
Yes.
No.
And unsubscribe?
Minus equals.
Yes. Okay. So let me show you one thing. I'll just create a new class, and I'll call it pour command. Pour command. And pour command will do something that we could have done without this maybe at first sight redundant stuff. So let's have an execute method in our pour command, and what we would do is our pour command would have contribution and name. Maybe it doesn't need a name. Let's say it doesn't, but we would need to do this. We would need to write line that pour command is starting. Then we would need to say that it's ending at the end if we didn't use events. And lastly, we would need to say that it is contribution. It has this contribution. 25, let's say, roughly. So in this case, we have 2 lines that we need, and we have 2 more lines that we would like to report. And you can see that those 2 lines mix in, and they're completely messing the readability of this function and messing its responsibilities. We don't want the command to always bring its report with it. Maybe sometimes we just want to execute and we don't give a shit about reporting it. And if we didn't have events, we wouldn't be able to separate the responsibilities. We could still keep firing events and not care that nobody took care of those events. That's fine. But it's not fine when you have something that you might not want. In this case, we might not want to print stuff to the console, but we are bound to it. And for that case, events are really useful to separate and have just what we need, and implement something that we need, that we might need in the future via subscribing to events from the outside. So that's why they're so handy. I think I covered all that I wanted. By the way, the command class and the thing for running commands, it's called a command pattern, but usually it has undo method, which is doing the opposite of what was done. In this case, it didn't have it, but a command essentially is almost like a delegate, meaning that it wraps some function in a class. It's not a variable, but it's like a function in a class. It's a bit different than a delegate. But it's just a bit of a side thing, uh, showing how you could play with events and how you could make nice code with an event. Alright, so I think that was it for today's lesson.
You did say these lessons are recorded, right?
Yes,
Because I will need to understand this a bit more.
okay. Do you have questions then? If you have something that you don't understand quite yet, you can go ahead and ask.
Not right now. I just have a broad of understanding of it.
Okay,
That's about it, really.
okay. Events are really useful because everything, like something that has a state that is quite big of an object, that is a process or something else, it so often has events. It usually has event that it started and ended. It has event that it's about to end, before start, after start. Like depending
I
on,
thought
yeah.
I thought events were mainly just used for like graphical user interface purposes.
No, no, not at all.
Not at all. Okay. Because so far that's what I've been taught for it to be used as.
Not at all.
Okay.
Like in this case, you saw that I had nothing to
That's
do
okay.
with
Yeah.
user interface, like
Yeah,
commands.
yeah, yeah,
Yeah.
Yes. So it's just okay.
In some cases, you might think that it's really useful to note some user, and as user I mean a developer, that something is happening. Like some important thing happened in your object, some state changed.
So it listens out.
Yes,
Okay.
and at that time, like specifically, you realize that you don't need to have an implementation, but you understand, you're aware of that in the future important things might need to be done when something starts or ends or a state changes, and you want to, and with events you can notify a developer that something happened, and the developer can handle it accordingly however he wants without enforcing some implementation that is done by you. You can let
Okay.
and give the freedom with the events. So
Okay.
it's very useful.
So will lessons like events and event handlers be taught differently?
uh,
'Cause-
well, event handler essentially is a delegate,
okay.
and that's all. And so it's a method. The method passed as as a variable, and that's all.
Mm, okay.
So
I get
it does, in my opinion, it doesn't need a separate lesson because,
Okay,
like
okay,
at the
yeah.
start,
Yeah, no, no, I
yeah,
understand it.
yeah.
Mm,
So those three that I showed, like basic, delegate, action, and function. Predicate, I think predicate is a different thing. I had a bit different understanding because I noticed it's basically it's a different thing. It's not like function and action. In any case, those three are something that you should be using. Actually, those two, action and function, is something that you should be using when handling events.
okay.
As an event handler, I mean. Um, right. And that's it, I think.
Okay. Yeah.
I
Sick. Thanks, dude.
you're welcome.
Oh, that's cool. Well, thanks.
Okay,
And
thank you for
And,
coming.
yeah, you're welcome. Rico is big gay.
No, you.
How do I leave? Wait.